Hello, everyone, and welcome to the webcast. My name is Christine Dorsey-Davis. I'm the Executive Director of the Ohio chapter of the American Planning Association, and I am your webcast moderator. Today is Friday, February 18th, and we will be hearing the presentation, Climate Science and Planning, the Basics. For technical help during today's webcast, you can type your questions in the questions box in your GoToWebinar tool panel. I will do my best to answer those. And for your content questions related to today's presentation, again, you can type those in the questions box, and we will answer those at the end of the presentation during the Q&A. I'll just ask that if your question is for a particular panelist, it helps me if you say who you want to answer that question, if you know. Coming up next on your screen is a list of most of our sponsoring APA chapters and divisions for 2022. Thanks to all those participating sponsors for making these webcasts possible and free to members. Today we're sponsored by the Sustainable Communities Division, so thanks to you for joining us on this series that you'll hear a little bit more about here in a moment, but just wanted to acknowledge today's sponsor. Coming up next is a list of our next two upcoming sessions. You'll learn more. Part 2 of this climate science planning, the intermediate level of this discussion will be taking place February 25th. And then we have another session by the ENRI division that will be taking place on March 2nd. We're actually booked well into the summer. So be sure to head over to our webcast website, ohioplanning.org/planningwebcast, to register for these and all of our upcoming sessions. Today's session is worth 1.5 CM credits, and then the new SR credit, 1 credit, so that is available to you. This has also been registered on demand, so if you can't make it through today's session, you will have the opportunity to view it later on our YouTube channel. That's where we post all of our sessions, and I'll talk about that in a moment. So don't forget to log your CM credits today by heading over to planning.org, log into your My APA account, and from there you can either search by today's title or the event number, both of which can be found on our website, ohioplanning.org/planningwebcast. If you're on social media, be sure to like us on Facebook. That's where I post any important date or time changes, and I also regularly post when we have new sessions available for you to register for and reminders of our upcoming Friday session. And like I mentioned a moment ago, we record all of our sessions and we post them on our YouTube channel. So be sure to subscribe to our channel so that you get notified when we have new sessions up and available. There are well over 350 sessions there already, probably closer to 400 at this point, for you to peruse and browse, some of which are available for on-demand viewing. Those are labeled, and it's also a list of our on-demand sessions are available on our website, again, ohioplanning.org/planningwebcast. That's the end of my housekeeping items. Again, if you have questions for our panelists, type them in your questions box. We'll get to those at the end of the presentation during the Q&A, and also in your GoToWebinar tool panel there, you will see that there is a handout available, and our presenters will speak more to that. But there is a download available, a PDF download in that handout. So take a look. If you can't find it, type a message, let me know, and I can try to help you out. So with that, I am going to turn it over to Carla Ebenbach, who is going to kick things off for us with the Sustainable Communities Division and talk a little bit about this whole series and this session. And I'm going to kick it over to you, Carla.
All right.
That presentation over to you, Rachel, and you're all set.
All right, well, we need the first slide, I guess. Welcome everybody to the Sustainability and Resilience series. So I'm Carla Ebenbach. I'm the Secretary Treasurer of APA's Sustainable Communities Division, and I'm chair of the steering committee for this webinar series. I'm a principal of a planning consultancy based in Southeast Florida, focused on sustainability and resilience policy and planning. Today's session will provide some important foundational instruction on current climate science and its relevance to planning practice. Once you've experienced today's event, don't miss next Friday's session as well, which will continue on the subject with 2 other subject matter experts taking a deeper look at the integration of climate science in planning practice, applications, challenges, and best practices. And if interested,
is it showing correctly?
yes, I'm almost to the next slide. I'll let you know.
Okay, I just want to double check because it was funky on my end. Thank you.
Pretty sure. And I was going to say also beyond next Friday, we have the basics of mitigation and adaptation sessions planned for March 11th and 18th, and registration has just opened for those. So next slide. So first, a little background. The Sustainability and Resilience series was created to provide learning opportunities for planning professionals. For many of you, these terms will be familiar, but they are always important to continually revisit and reconsider. For the purposes of this series, planning for sustainability means balancing social, economic, and environmental resources, incorporating resilience, and linking local actions to regional and global concerns. Meanwhile, planning for resilience means supporting the capacity of individuals, communities, and systems to survive, adapt, and thrive in the face of chronic stresses and acute shocks, and even transform when conditions require it. Next. The SNR series, as we call it, is offering diverse perspectives under this wide subject matter umbrella over roughly 2 years, aiming to explore 12 topics in formats that cater to both those who are new to the subject matter and those who are more familiar and experienced. And this could result in as many as 24 events by the end of 2024. You can earn AICP-CM credit for either the live or the on-demand version of any series session. The recordings are becoming a library of resources available at no charge and already available for viewing on demand on the Ohio chapter platform are 2 sessions which we held in September on extreme weather trends. And today's and next week's sessions will be available there soon as well. So any of these will earn you the new mandatory SNR CM credit. And a word about this credit, as you may have heard by now, this is a new CM requirement for AICP planners along with equity as of this year. So any live or on-demand session that you attend can earn it in this series. There will likely be other sources outside the series for earning the credit as well. And we came to develop this series because of our work in developing the AICP credit, and in the process became aware of the real need for more learning opportunities. And we weren't the only ones to feel that way, because we have had volunteers come out from a whole host of APA divisions to guide the series with their expertise and their diverse viewpoints, and we welcome more involvement. So anyone interested in joining our committee or in being a speaker on a future webinar, we're looking for planners as well as other professionals and subject matter experts. Please reach out. And I'll be happy to discuss with you. Upcoming sessions are going to get into such topics as the basics of mitigation and adaptation, as I said, public health, technology tools, economic strategy, preparedness strategies, policy tools, among others, all as related to sustainability or resilience. And all sessions will endeavor to meaningfully examine social equity implications within the presentation and raise the bar for how marginalized communities are embraced in the planning process. So next slide. So on to the program. Our first presenter and moderator today is Matthew Bucchin, who is AICP and a lead Green Associate. I have the privilege of working with Matt through the Sustainable Communities Division, with which he is the immediate past chair. So next, Matt's going to introduce today's subject, as well as Rachel Riley of the University of Oklahoma's Southern Climate Impacts Planning Program, who will follow him with her presentation. So Matt, I am handing it over to you.
All right, thanks Carla, and thank you all for joining us today. I'm pretty excited to be speaking with you about this exciting topic. As Carla was saying, a little bit of my background. For my full-time job, I'm a regional practice leader with Halff Associates. We're a mid-sized full-service AE firm that has 27 offices all across the South. I have the pleasure of overseeing about 75 planners and landscape architects who cover the full spectrum of long-range planning all the way through implementation and construction administration of designs that we do. As what I call my second job, I've spent the last decade working with and volunteering for APA Sustainable Communities Division. As Carla mentioned, just the immediate past year, I spent 3 years as that. And as it relates to this topic, I'm one of the core authors of the 2020 APA Climate Change Policy Guide, as well as the co-author of the forthcoming APA Climate Change PS report, or Planner Advisory Service. Next slide. So real quick, just to kind of cover what we're going to be talking about, I'm just going to really introduce the topic, make a tie to why I think all of you on the phone need to be paying attention and getting up to speed on this topic, do a quick introduction to climate change that Rachel's going to be carrying forth. She's going to really dive into the topic itself and talk about some of the data limitations, the resources that are available, and then I'm going to come back at the end and wrap up about some of the resources that APA and Sustainable Communities Division and other volunteers have pulled together for you to start moving forward on the next steps. Next slide. So I typically would start off these presentations. I've done this, various times across the country and throughout the years. And I typically do a quick look at what's going on in the news. And every time I do it, it seems like there's just more and more news. So just coming at the end of 2021, it's been listed as the 5th warmest summer on record. The last 7 years have been significantly more warmer than the average. And if you really look into the data, we're talking about a 40-year trend where every year for the past 40 years, we have been significantly above and increasingly above the global average that it was in effect for pre-industrial conditions. So what does this mean for planners? Next slide. We're really thinking about a topic that is not only bad for us, but getting worse. And it really affects every one of us and every one of our communities on the phone. And it doesn't mean that it's going to impact us all the same. So you can see just this slide where it really talks about, here are some of the predominant ones that your region's going to be dealing with. Next slide. But what the other important part of this is not only is the warming of the earth getting worse, the impacts from that are also getting worse. So this is a snapshot of 2021. We had over $20 billion natural disasters that were caused predominantly because of climate change. And it's a thing that's getting more increasingly worse, as well as increasingly more damaging to our communities. Next slide. So what does that really mean for planners? There's topics on here that you need to know about, that you'll start to increasingly be involved with. There's ones on here that it's more of things that are happening that may not affect what our daily jobs are. But from the standpoint of what you do as a job in the US, you're going to be spending more of your time thinking about how these intensifying impacts are becoming these extreme weather events, our coastal communities and sea level rise, increases in inland flooding, and then on the opposite part of the spectrum, sometimes the exact same time, increased drought and extreme heat, extreme fire activity, and then two others at the end we don't necessarily spend as much time focused on, but we need to. One is how we're losing our biodiversity and what that means for our communities. And the last one is extremely important. And it's not just about the species migration of plants and animals. It's really about what we're going to be seeing in migration of our human settlements. Whereas more extreme weather events happen inland and flooding, as our coastal communities change, we will be dealing more with how we transition some of our communities or shut down some of our communities so that we can protect our people moving forward. Next slide. And then as what you do in an everyday basis, we need to broaden the conversation about climate change from extreme events and really start getting into how it affects our natural and built environments. So our changing energy portfolio and how we get our energy, how we need to change our land use patterns, whether it's from where we settle to the type of development that we build, and how do we need to change our infrastructure. So as the planet continues to warm, all of our engineering standards are built off of standards that were based on the norms that were there for most of our history. and those norms are now changing. So when we think of consistency of road pavement, we think of things that are not built to withstand changing temperatures. These are things that we're going to have to spend more time talking about. Next slide. And then so it really comes back to, why do you need to be on this call? If you look at the news, you look at a lot of our allied professionals, everybody's talking about climate change and how they need to impact the way they do things. But from the standpoint of thinking that climate change is going to affect everything that we do and every aspect of our built environment, our communities, we are really the only profession that brings the right expertise to address this from the standpoint of a leadership perspective. And we can't do it on our own. We have to partner with all of our allied professions. But we're the only group that truly has a comprehensive perspective that looks at all facets of our community, how all of our different systems interact with each other. We're the only one that's really tasked with not looking out, the next 5 years of a project, but the next 20, 30, and 50 years for our communities. We're the only one that are focused on these place-based solutions and how the built environment affects the overall growth and development of communities. And then we, as a profession, we spend all of our time engaging our communities, doing facilitation and consensus building. These are things that are going to be increasingly needed as we work through some of the increasingly detrimental and a growing list of competing priorities. There's going to have to be compromises made, and a planner skill set should be at the table leading these conversations. And then the last one is really about where we are situated in our communities. And when you think of the role a planner plays in the comprehensive planning process and writing regulations and interacting with all the other things going on, whether it's from the infrastructure, utilities, whether it's hazard mitigation, we are uniquely positioned and in a process and a place that gives us the ability to interact with all these different things going on. So I'm going to turn it over to Rachel Riley. She can introduce herself, but she is from the Southern Climate Impacts Planning Program. We've had I've had the pleasure of presenting with her before, and she's going to really walk you through a great introduction to climate change mitigation and adaptation. And with that, I'm going to turn it over to Rachel.
Thank you so much, Matt. Hello, everyone. It's great to be with you all today. My name is Rachel Riley, as Matt said, and I am not a planner, but I am with an organization called the Southern Climate Impacts Planning Program, also known as SCIP. And our mission is to assist organizations with making decisions that build resilience by collaboratively producing research, tools, and knowledge that reduce weather and climate risk and impacts across the South Central US. So we serve the region that you see on your screen. And we're funded by the National Oceanic and Atmospheric Administration, or NOAA. We're multi-institutional, multidisciplinary, and planners are one group that we work with. My background is in meteorology and climatology and communication. And over the last several years, I worked pretty closely with planners, particularly in Oklahoma and Arkansas, and now a little bit in Texas. And we've done things such as conducting some exploratory workshops where we're trying to promote collaborations amongst planners and emergency managers in the region. We've developed what we call our simple planning tools that I will talk about towards the end of my presentation today, that help give you some access and point you to the historical data tools and future trend information. I've also worked with several of the state APA chapters in our region, or in my region, and presented at various conferences and meetings, and involved into several activities. So I've learned about the planning context quite a bit the last several years, and I'm excited today to present to you some information about climate. So let's start off with some very basic information about how we determine weather versus climate. Weather is the state of the atmosphere at a particular time and place, and mainly with respect to life and human activities. And there's different weather phenomena, such as tornadoes and rainfall and snow, clouds, lightning, etc. Climate has more complex definitions and has multiple definitions depending on what time scale you're talking about. So one definition is the statistical collection of weather conditions at a place over a period of years. Climate is also the accumulation of daily and seasonal weather events over a long period of time, and this can be from weeks to years to centuries. Climate includes weather and weather extremes, such as some of the ones that Matt mentioned a little bit ago. And it's represented by long-term averages of weather variables and departures of weather variables from those averages. Another way to look at it is this. Weather determines, for example, the type of clothing we wear today, whereas climate determines the type of clothing we buy and keep. Weather determines whether our city puts out snowplows today or not, and climate determines whether our city should even purchase snowplows in the first place. So in general, weather determines operations, and climate determines planning and design. And this fits really well into what Matt was just talking about, how I think the planning profession overall can really play an important part in dealing with our climate-related challenges that we face. So here's an example in graph form of climate. This is what you could call the annual climate for Oklahoma City, Oklahoma. And let me see if I can pull up my, I'm hoping this will show up on my laser pointer. If one of the panelists can tell me if you can see this laser pointer, that'd be great. Thanks. So this graph is showing,
we can see it.
Okay, awesome. Thank you. What climatologists called climate normals, and really that just means a 30-year average that's updated every 10 years. So we have the maximum and minimum normal for each day of the year. And this solid line in the middle is the overall average for the entire calendar year. So then let's add on the data from 2021, which is all the squiggly lines you see. And again, you have maximum and minimum, and then the average for each day. Well, from this graph, we can pick out some weather events. In mid-February of last year, so actually almost about a year ago, there was a significant extreme cold event that hit South Central US, caused some major issues. I'm sure if any of you are from that region, you remember it very well. And you can see just how anomalous some of the cold temperatures were compared to what is the climatological normal. Another example was in mid-April last year, kind of mid to late April, we had a pretty late spring freeze, for at least late for Oklahoma City. And those late spring freezes can cause problems, especially for agriculture. Then on July 4th, we had a relatively cool July 4th. It was only in the mid 80s, which for Oklahoma City was pretty cool. And then towards the end of last year, there were several days in December that reached almost 80 degrees, which ended up being the warmest December on record for Oklahoma statewide. So here's another example of looking at climate, and this is the annual Minnesota temperature trend, so a different state. And this graph goes from 1895 to present, and you can see that there has been a clear warming trend the last couple decades, whereas previously there was a lot more variability, and now it's been significantly warmer and consistently warmer. So what actually determines climate? One thing that's important to understand is the Earth-atmosphere energy balance. Now, I won't go into all the numbers on the screen, but some of the main points are that essentially incoming energy from the sun heats the Earth. Some of that energy is reflected by clouds or the atmosphere back into space, and some of it is absorbed by the Earth and then re-emitted. And there are atmospheric gases that trap some of that energy, which keeps the Earth at an average of 58 degrees Fahrenheit. Now, thankfully, we have these atmospheric gases because otherwise the Earth would be about 0 degrees Fahrenheit, which would not make it very inhabitable. So one factor in determining climate is the sun and uneven heating of the Earth. So places like around the equator receive more direct sunlight more often, get more direct energy, and then places farther away from the equator get less direct energy and are colder. We also have the revolution and tilt of the Earth, rotation, latitude differences cause different climates, and also elevation. The higher in elevation, the cooler the climate you are. These pictures on the bottom are an example of places that have the same latitude but different elevations, and therefore their average temperatures are really different. So Mount Washington, New Hampshire sits at about 44 degrees north latitude, as does Rapid City, South Dakota, but Mount Washington is quite a bit higher up, about 6,300 feet above sea level, and its average annual temperature is 27 degrees Fahrenheit, whereas Rapid City is about 3,200 feet above sea level, and its annual average temperature is about 46 degrees Fahrenheit. And then another factor is that land and water are different. So land surfaces heat and cool much more quickly than water. So in addition to those kind of geographic factors, we also have factors that affect kind of just how the atmosphere functions. So we have solar variability. The sun cycles about once a decade and goes through minimum and maximum periods to have more or less radiation. We also have ocean circulations that cause, depending on how the ocean is circulating and different points in the oceans, different areas are warmer and cooler. Then over very long periods of time, we have tectonics that shift, and mountains decay and increase, and that's on very, very large time scales. And then our atmospheric gases can affect the climate. So one example is volcanic emissions, which when we have a very large, intense eruption, that sends particulate matter up into higher in the atmosphere, which can actually have a cooling effect. So this example on the screen is from Mount Pinatubo in 1991, excuse me, that you see on this graph. After the eruption occurred, there was actually the globe cooled for a couple of years because of that eruption and how much particulate matter was in the atmosphere. So with those natural forces, or natural factors in mind, let's then get into climate change. I mentioned a little bit about atmospheric gases. There are 4 gases that comprise about 99.998% of the atmosphere. Most of that is nitrogen and oxygen. There's a little bit of argon, about less than 1%, and then carbon dioxide is 0.033% of the atmosphere. Then we have water vapor, which also is important in creating our weather conditions, and that's present in variable amounts from near 0% to up to 4%. Now you may look at this carbon dioxide percent, and it's a very small number percentage-wise. And that is true. However, it has been increasing significantly the last few decades. So what this graph is showing is present day is on the right where it says 0, and then it's looking back about 800,000 years. Now, we weren't able to directly measure carbon dioxide 800,000 years ago, so scientists use proxy measurements such as ice cores to determine the carbon dioxide concentration. So prior to the measurement period, the highest previous concentration of CO2 was 300 parts per million. But now, since we've been able to measure it directly the last 6 decades or so, the carbon dioxide has increased to 412 parts per million. So this is a significant jump, again, when you compare it to the past long history. And again, if you think back to that percentage, it wasn't actually, the percentage of CO2 in the atmosphere isn't that much, but a small amount can have a big effect. So what happens with CO2 is that when it goes in the atmosphere, it ends up sticking around for 50 to 200 years. And so that CO2 traps heat and continues to build up, and that's what's contributing to our warming. Another greenhouse gas that's also contributing that we don't have as much as, it doesn't last as long, is methane. And methane actually warms the atmosphere even more than carbon dioxide. So the same amount of methane warms the atmosphere 21 times the amount that carbon dioxide does. So that increase in carbon dioxide has led to an increase in global temperatures. So this graph is showing from 1880 to present global land and ocean temperature anomalies. So this is not just the land surface, but also oceans. And oceans are important because they hold a lot of heat. They don't change as quickly as land, but they play a very important role. So obviously, there's been a clear warming trend, and this calculation is based on a kind of recent 40-year period compared to the early 1900s. Here's another look. This graph is showing about 2,000 years worth of temperature data, and similar to the carbon dioxide graph I showed, some of this is based on reconstruction from looking at ice cores and tree rings and pollen deep in the earth. So again, on the right side is present day, and then the left goes back about a little over 2,000 years. This gray shading is kind of the uncertainty, whereas this darker squiggly line is what that average number is for temperature. So you can see that until, even the early, it's clearly been a warming trend here, but even in the, say, early 1900s, it's still kind of matched up with the previous, but lately, the last several decades, the warming has just been, much more significant than anything in recent history. And the rate of change is very fast compared to the past. So how do scientists know that, just because we've seen this warming, that it's due to carbon dioxide? What climate modelers can do is, in their models, they account for carbon dioxide and they can either add it in or remove it. And what they have done is construct the global surface temperature from 1850 to present, and the blue shaded area is the temperature that the models are simulating when only the natural factors are considered, such as the changes in solar variability and volcanic eruptions. And then they also model it with carbon dioxide, and which they call human factors. And that is represented by the kind of tan color here. So then what they do is overlay the observed temperature based on actual historical data, and that is characterized by this black squiggly line. So you can see that the observed temperature from actual data instruments, weather instruments, follows the model that includes the carbon dioxide. And one brief note about models, the climate models, is that they've gotten increasingly sophisticated over the years. They used to be relatively simple, and now they have all sorts of components that just make them a lot more representative of actual climate. And not only have they become more sophisticated, they've also gotten, they have increased spatial resolution. So this figure is a little bit outdated, but it still gets the point across. So in 1990, the what we call grid spaces looked about this large. The orange and the green represent land, and the blue is water, oceans. And then with increased computing power and whatnot, those grid spaces have decreased, which allows us to understand more specifically about how the climate is projected to change in more specific locations. Now, even with these improvements, there are still limitations. The models have a hard time resolving things such as tornadoes and very small scale phenomenon, but overall they're really quite good, especially on larger scales. So what then climate scientists will do with the models is project how carbon dioxide is then going to affect temperature. And this left graph here is showing different scenarios for carbon dioxide. So that basically means different amounts of carbon dioxide that's going to go into the atmosphere. And then on the right, they're projecting temperature based on those scenarios. So what you can see is that even if we were to significantly decrease the amount of carbon in the atmosphere almost immediately, there's still going to be a warming. So we better prepare for that warming that's going to happen. Now, you may be thinking as you're looking at all these graphs, do a couple of degrees really matter? Is that a big deal? I don't have time to go into it today, but I would encourage you to check out one of the videos that Dr. Catherine Hayhoe has done on YouTube called What's the Big Deal with a Few Degrees? And she's got many videos in her Global Weirding series that are kind of, several minute clips that kind of break down all these concepts if you're interested in more information. So Matt briefly mentioned some of the climate change impacts and indicators, and I don't have a ton of time to go into those, but I did want to mention just one that we're seeing, which of course is Arctic sea ice declining. And one message that doesn't always get communicated very much is that although, yes, it's declining, but the ice is also becoming younger, which means that it can melt even faster. So this figure on the left is from March 1985, and the white ice, white color you see represents ice that's over 4 years old, whereas the blue is younger in age. And you can see that when we go to March 2021, there's hardly any white or 4-year-old or older ice left, which is pretty significant, especially just over a relatively short period of time on a climate scale. So with all of that said, I wanted to mention this latest statement from the Intergovernmental Panel on Climate Change, which is a global group that has authors from many, many different countries and many, many different institutions all coming together to write one report. And they say that right now it is indisputable that human activities are causing climate change, making extreme climate events, including heat waves, heavy rainfall, and droughts more frequent and severe. So on a very grand global scale, the science is pretty much settled that humans are affecting the climate. Now, as I'll get into in a little bit, what is not always settled is some of the exact details on how that's playing out. So let's now go into climate change and projections for the US. And hopefully in these slides, you can find some information that's relevant to you in your area or the areas that you work in. I realize that I'm providing a ton of information and that can kind of be overwhelming at times, but hopefully you're able to pick out some things that are of interest and of value to you. So this first map or set of maps is the temperature change from a recent 40-year period compared to the early 1900s. And you can see that there's been warming in most places. The obvious standout is the Southeast US, where there was actually a cooling trend over the period. And this warming hole, so to speak, was found to be due to reforestation practices. So a lot of trees were planted and have grown up and actually had a cooling effect on the region, at least for the time being. It's starting to go away now. So another thing to point out is that winter temperatures have warmed more than the summer in some places. So, you know, extreme heat is often a focus, which it is a big deal. But winter temperatures have actually warmed more, especially in the northern latitudes. So let's zoom in for a moment to one state to give an example. This is for the state of Vermont, the temperature trends from 1895 to present. And you can see, again, a clear warming trend, especially the last 4 decades or so. And this has significant impacts and implications for the ski industry there and also maple syrup production. These maps are showing projections. So I was showing historical data, and now I'm showing projections. The map on the left is projected change in number of days above 90 degrees Fahrenheit, and then the map on the right is projected change in number of days below 32 degrees Fahrenheit. So I added a couple of arrows and just to point out a couple of examples, how many more days that would be over 90. So if we look at Eastern Oregon, about 20 more days above 90 degrees, Kansas, about 30 more days, and then parts of Florida, up to 70 more days above 90. And then similarly for below freezing, a lot of basically, you know, fewer days below freezing. Northern California and the Sierra Nevada is about 30 fewer days below freezing. And in New York, about 20 fewer days below freezing. So let's move to precipitation. This is showing a precipitation change, again, for that kind of 40-year period compared to the early 1900s. And in a lot of places, there's been an increase in annual precipitation. Other places, there's been a drying. It's kind of, you know, in some parts, like in the West, it's hit or miss. It's variable, and similarly with Alaska, some parts have gotten wetter, some have gotten drier. But one thing that is happening as well is that the intensity of rainfall is increasing. So these are projections for changes in the 20-year extreme precipitation values. So what that means is the rainfall that you can expect to occur about once every 20 years, at least based on the statistics. For reference, I have on the right a couple of examples of what the current daily 20-year events are. So for Pittsburgh, Pennsylvania, that's about 3.7 inches is a 20-year event. Nashville, Tennessee, it's about 5.25 inches. New Orleans, Louisiana, is about 10 inches. And Tucson, Arizona is about 2.8 inches. So what you can then do is take this mid-century, so mid-century is around the year 2050, late century is around the year 2100. These are percent increases. So you would take, for example, Pittsburgh's 3.7 inches and add about 13% for mid-century, and then add 22% onto that for late century. Okay, the next hazard is drought. Drought is a natural part of our climate, and there's different kinds that have different effects. So we have meteorological, agricultural, hydrological. it can really be a complex, and we call it often a creeping disaster, because it's not like a tornado or a flood event that's going to happen, quickly. So currently, the 1930s Dust Bowl era remains the drought of record for the U.S., at least by geographical scale and duration. That said, we know that the Western U.S. is currently in a drought that I know there's a study that just came out this week saying it's the worst in 1,200 years, and I'll get into that in a second. But I want to point out this finding from this Climate Science Special Report, which is part of the National Climate Assessment, which is our kind of authoritative document for our country. And they said this in the most recent one, that the human effect on recent major US droughts is complicated. Little evidence is found for a human influence on observed precipitation deficits, but much evidence is found for a human influence on surface soil moisture deficits. So they're saying is that climate change, at least so far, isn't necessarily making the rain stop or decrease, but warming temperatures are exacerbating the soil and drying it out faster, which then can exacerbate droughts. We also, of course, need to consider that the population and the built environment has increased, and so that is, even if we kept the same amount of water resources in one place, if you're increasing the population, you're increasing the demand on that water, which makes it more challenging. And also, again, the water is going to evaporate more because of the warmer air temperatures. So I mentioned that a recent study, and some of you may have seen the headline, so I wanted to mention it today, about that the Western, they're calling it a mega drought, is the worst in 1,200 years. And there's some interesting findings in that the authors are saying that roughly 1/5 of that mega drought can be attributed to human-caused climate change. So they're not saying all of it is, but they're saying part of it is. And then last year on the Colorado River, which those of you in the West know is a major source of water, federal water managers had to declare the first ever water shortage, which triggered water cuts to the river's 40 million users. So my point in all this is that drought, it is naturally occurring, but there are climate stresses that are happening that are making it worse at times. And one of those also is decreasing snowpack in the Western US. Again, snowpack is a primary source of water and allows cities in the Western US to survive throughout the summer because of the runoff in the reservoirs. And the image on the far left is showing essentially historical snowpack. And as you go right, it's showing mid-century and an end of century projection. So the snowpack is decreasing. Snow is melting earlier in the spring than it used to, which then, again, by the time you get to summer, can cause problems if you've already used up the water that you've been allocated. So definitely something to pay attention to. Also in the West, and not just the West, but the West has been in the news, the last several years with regards to wildfires. So the current data are showing that the frequency, just in pure numbers, of wildfires is not really increasing or decreasing, but the amount of area burned is increasing. So fires are actually good for ecosystems. There's a natural part of ecosystems. It helps with healthy ecosystems. But we take climate stressors along with the built environment where people are living in places that were previously uninhabited, and then also historical fire management practices where there was a period where there was no prescribed fire and no burning because people wanted to keep all the vegetation. Well, what happened is some forests became overgrown, and now there's a ton of fuel. So when fires do break out, there's just so much fuel that they burn hotter and are more destructive. Okay, then jumping to severe storms, which in this instance, I include tornadoes, wind, and hail. The story with severe storms is kind of also complex. The graph you see is showing historical annual tornado activity in the entire US from 1955 to 2013. The black line is the days per year with at least one tornado across the country, and then the red is days per year with more than 30 tornadoes. So what you can see from the graph is that there was actually a slightly downward trend in the number of days that tornadoes occurred, and a slight upward trend in days what we call tornado outbreaks occurring. And so scientists are projecting that trend to continue, potentially with possibly more tornado outbreak days, but not necessarily more tornadoes overall. And similarly, there's a projected increase in severity and frequency of severe thunderstorms, but right now there's low confidence in that projection, and this is mainly because of just the model limitations with not being able to resolve these very, very small scale phenomena. That said, even if the overall tornado activity is not increasing, we're still going to have increased damages and increased impacts, and including economic impacts because of increases in population and the built environment. So now let's move towards the coast and talk about sea level rise and high tide flooding. So high tide flooding is when there's not actually any rain falling, but there's flooding that occurs due to high tides. And high tide flooding has become increasingly more common, especially in the last decade, and it's pretty astounding. There's a couple of tools that exist where you can go into specific cities and look at how many high tide flood days have occurred and what the projections are, and it's pretty astounding in some cases. So what happens is the example you see in this picture where maybe roads are flooded, you might even have businesses flooded depending on how bad it is. People can't drive, sewer could be overflowing, so it's very, very disruptive and it can be damaging. And this is due to sea level rise, which you see on this blue squiggly line here on this left chart. So globally, sea level rose 4 to 5 inches between 1901 and 1990, and then an additional 3 inches has occurred since 1990. So basically, it's accelerating, and a substantial fraction of the rise is due to human-caused climate change. The image you see on the right is for a projected relative sea level rise for the year 2100, and you can see that the worst areas projected is to be the parts of the Gulf Coast and then kind of northeast US, but even Florida and Mississippi and whatnot, still projecting a 3 to 4 feet in sea level rise by 2100, which is, again, it's kind of mind-boggling to even understand what that means. But I know places are already having problems with sea level rise right now in the year 2022. So here's another coastal, primarily coastal issue, being hurricanes and tropical storms. This graph is showing the continental US landfalling hurricanes from 1900 to, I believe this is, 2017. And there really has not been that much of a change in the total number. There's a slight decreasing trend, but it's not statistically significant. However, there has been an increase in the number of storms that hit that are more intense, and that projection is, or we're projecting that to continue. So more of the hurricanes, when they do occur, are more intense, which of course is either more wind damage and increased rainfall rates. And then as far as frequency, the current projection is that the total number of hurricanes and tropical cyclones will either decrease or stay the same globally. So similar to the tornado trend, where it's maybe not necessarily more storms overall, it's more like when they do occur, more of them are intense, leading to more damages. So with all of those in mind, which I realize I presented a lot of information, but the point is that we all experience hazards in our locations, and some of them are being exacerbated by climate change, and climate change is making them worse. We also have the built environment, and populations are increasing, which exacerbates impacts. So what can we do about that? How can we deal with the challenges that we're facing? There are two main ways to describe climate action. One of those is climate mitigation, and one of those is climate adaptation. Now, there's a lot of definitions out there that are really kind of long and long-winded. So what I did is came up with some simple definitions that I thought might resonate with you all. So climate mitigation is reducing greenhouse gas emissions through energy reductions and transitions to renewable energy. So things such as solar panels or wind turbines or other non-fossil fuel sources. Then there's also climate adaptation, which is altering planning practices in the built environment to reduce and better manage climate risk and impacts. Some people will also talk about hazard mitigation, which in a lot of instances is basically the same thing as climate adaptation, but make sure that if you are talking about mitigation, that you clarify whether or not you mean climate mitigation or hazard mitigation, because I have been in conversations and been in meetings where people, I think, end up talking past each other because they're using the same word, but they mean different things. So I'm not going to get into today much about this because as I understand it, a future webcast is going to talk more about all the actions that planners can be involved in to address these issues and help deal with the climate-related challenges that we are all facing. But I do want to leave you with a few resources before I pass it back to Matt. So these resources are primarily the kind of climate and hazard data focused resources. If you're looking for, and these are the ones, by the way, that Christine said are on the handout. So I'm going to kind of go through these fast, but more information is on the handout and you can look at them yourselves. The first one is the simple planning tool, which I mentioned up front, and it compiles all the historical data tools into a format that's very simple, provides instructions, it's organized by hazard. This is available on the SCIP website, southernclimate.org, if you click on our data tools tab. Now, we have versions that are tailored to 2 states, and I know you are all from around the country, but a lot of the tools that are listed in these are relevant to multiple states, if not all states. We're about to have a version for Texas available, which will include coastal tools. So if you're on the coast, the Texas version will have tools available relevant to you. If you're in the Western US, like west of the Rocky Mountains, one of our colleagues in Utah developed a version of this tool for Utah, and that tool will have a lot of the Western US specific tools like snowpack and those kind of things. If you want a kind of just a narrative, a short narrative to read that's relevant to your state, there are these state climate summaries available, produced by a group in North Carolina in conjunction with some NOAA groups. These are nice because they're pretty short. They're about 5 pages, and they provide narratives and the latest on climate change for your state. But the limitation is that they don't provide information on all hazards. So it may not provide all the information that you need. And then if you really want to dig into a lot of information, there's some wonderful reports from the National Climate Assessment. The 2017 report focuses on the physical science and physical climate updates, and the 2018 Volume 2 report focuses on impacts, risks, and adaptation and actions. And these are really great reports, but I will warn you, they're very, very large. There's a bunch of different chapters, and so you can get a lot of information. You can easily pull graphs and maps. In fact, a lot of what I showed today are from these reports, but it may be too overwhelming, and it may be too much for what you need. So, and I think, oh, and the last resource I want to mention is teams that are like my group, but in other places in the US. So the place that you see colored on this map are currently covered by what are called NOAA Regional Integrated Sciences and Assessments teams, and they do work similar to my organization, SCIP. And so if you're in one of these areas, I encourage you to go Google them and go to their websites, and they're going to have information and tools that are specific to your geographical area. Okay, and with that, I'm going to pass on to Matt to give a couple of brief APA resources and planning resources.
Thank you, Rachel. What a great introduction to the science of climate change and how planners are going to need to, really get up to speed on being able to talk about this and understand how this intersects with what we do on a daily job when we're working with our communities. So I'm just going to really quickly jump through some resources that APA, particularly the Sustainable Communities Division volunteers have been working to pull together over the last couple of years. These are specific tools that are available on Sustainable Communities Division's website at apascd.com under our resources tab. And it's a resource area that we're going to be adding additional resources moving forward. One that is in the works that I mentioned at the beginning, which I can't present on today, is the forthcoming Climate Change Mitigation and Adaptation PAS report, or the Planner Advisory Service. That should be published in the next 2 or 3 months. And what's really good about that is it actually dives into and summarizes a lot of the things that we just went over, including pulling in a lot of the relevant information from the NCA 4, the National Climate Assessment 4 by the US Global Change Resource Program, IPCC, things of that sort. But all these things are pulled together so that you can have a single resource to really get up to speed. So a couple of the tools that are already available ready for you is APA's 2020 Climate Change Policy Guide. What's really good about this is it's an additional or a climate change focused resource for planners that was developed around the APA Sustainability Comp Plan standards. And you can see kind of the 6 topics that were on there. What I really like about that is it forced the authors to develop climate change specific policies covering a much broader spectrum of things that we interact with, versus if we wouldn't have done that, it would just been kind of doing the same thing, a couple topics here and there. And this really made us kind of broaden our conversation. But this this resource basically has 7 overarching policy statements that have explanations of why they're policy statements. They have 51 specific policy statements that you could pull into long-range planning, development review processes, things of that sort. But what really is good about this is that it also has 253 strategies that are built into those policies that already detail some of the next step things that you could be pulling into your action plans and things of that sort. So it's a really great resource. Please take some time to go check it out. Next slide. Another tool that is developed by Sustainable Communities Division is a data collection process guide. This is something that some of the resources that Rachel just showed you, but basically it's a resource that we built in conjunction with the Great Plains Institute to really try to pull together a whole host of available national resource databases and platforms so that you can have a one-stop shop for going to grab these things, so you don't have to start from scratch. Next slide, please. This is just an actual example of what it looks like. You can see, you can't read any of this, I understand that, but it breaks it down into different categories, describes it, and then kind of shows you who has the resources and gives you a link directly to that. But you can see it covers different topics, from how do we talk about this with buildings, and what resources do we have for transportation, demographics, et cetera, et cetera. Next slide. Our next resource that has been developed is, we oftentimes pull together this background research, and we tell you why it's important, and we give you the facts, but we don't close the loop on that many of our planners out there, our current planners, are really involved in the day-to-day business of development review and rezonings and plans and plats. And so we pulled together a resource, again, in conjunction with the Great Plains Institute, to kind of help you identify ways that you can integrate climate considerations into the development review process. I think we go one more slide on this. Actually, I think that was the slide. And then the next resources that we have out there is a very comprehensive summary or database of existing model and actual ordinances out there that are developed in ways to help advance the needle on climate change mitigation, climate change adaptation. You can see a screenshot from there. You can filter by topic, you can filter by area, you can filter by jurisdiction size, but these are a resource or a database of ordinance out there, so that when you're working with your community to develop regulations that impact the private sector and their private development, you can go here to find examples without having to, really draft everything from scratch. Next slide. And then these are a couple slides. I have about 2 or 3 more slides that are things that are in the upcoming climate change PRS report, but it does lay out some overarching principles that we feel that planners should be thinking about as it relates to climate change. One is we kind of have to get out of our silos of thinking in all of our individual roles and responsibilities, and we have our planners doing this and our engineers doing this, and we have our emergency managers doing this. The very nature of planning and how we work with our communities, we need to be thinking about how to break down those barriers and think of how what one decision interrelates with a whole bunch of things out there, and facilitate those conversations. Being flexible with how we're coming up with things, there's no one right answer, but we do have to make advancement in this. How we can try to capitalize on solving multiple things by one decision, by thinking those cross-sector, diverse, flexible strategies, making sure that we're not keeping our plans high level and overarching, but really diving into details so that we set the stage for implementation. You always hear we don't want to develop our plan to sit on the shelf or whatever we're doing. We need to get to action, and we need to get to action fast. And because of the climate emergency or climate crisis or whatever topic or classification we want to call it, we have to be ambitious what we're doing, but we have to make sure that we're being realistic and let those things be achievable. And then our very nature of what we do with our communities, we probably need to be the ones that are not only engaging our constituents, engaging our appointed and elected officials, but educating them on what we can help influence where we're going, and make sure that everything that we do is fostering equity and protecting those vulnerable and disadvantaged populations, which are typically the ones that are also the most impacted by climate change impacts that are occurring today. And then building the interdisciplinary partnerships. While I feel that planners need to be in the lead, we also need to make sure that we are fostering those partnerships with our allied professionals. Next slide. And so as part of the climate change PRS report, we did pull together kind of a 10-step process for climate action planning with a foundation on the 3 in the center: consensus building, engagement, and education, and then walking through making sure that we've identified steps all the way from developing our champions in the beginning of the process so that they're in place for implementation, and making sure that we're not only completing one project, but setting the stage for a continual evaluation for the next step that we update things. Next slide. And then one of the final things that you'll see in that PS report is it's a pretty comprehensive resource about climate science, climate mitigation, climate adaptation, just a whole host of resources. And if you're sitting there thinking about what do I do next? Well, we have 4 things that we talk about to set the stage, 4 little things. And one is, continue to get educated on webinars, do some reading, join some podcasts, things of that sort, so that you're able to speak more informed about the topic and how it interrelates with what we do. And then number 2 is really, I had to give full credits, and Rachel mentioned it earlier, but a wonderful resource, Catherine Hayo with the Nature Conservancy. She's got whole webcasts and TED Talks really saying, the best way that we can advance the conversation of climate change is to talk about it. Talk about it with your friends, talk about it with your family, talk about it at work. And the more people that are talking about it, the greater movement that we'll create to actually get to action. And then planners need to network with ourselves. We'd love for you to join the Sustainable Communities Division. We'd love for you to network with each other and make sure that we're using each other to build this movement for getting a response to climate change. And then to really promote policy and take action. And when you get into the PS report, when it comes out, policy is very broad. It could be conversations, it could be training, it could be actual policies, it could be regulations, whatever your form of policy, whatever form of policy you have influence over, it says take that step to kind of integrate the next step action. So that's kind of the planner commitment that we hope that you all take away when that resource comes out. And I believe that may be the last slide before we go to Q&A. Back to you, Christine.
Wonderful, thank you. Let me get my webcam on. We're going to jump right in, and let's kind of pick up right with your last slide about sort of the planner's takeaway on this. So you spoke earlier to the planner's role in community engagement, facilitation, and consensus building, and that the need for these skill sets will increase as we face situations that call for difficult compromises. So how can planners and communities prepare for this challenge? Who should we be partnering with? Who should we be having these conversations with?
Excellent. Okay, well, I'll just jump in real quick and then turn it over to Rachel. So we're already in this role. We already play this role in a lot of our communities, but I've in my 25 years experience with it, it's about 2/3 of it in the public sector, 1/3 of it in the private sector, is no matter which sector you're in, we still kind of operate in our silos. When I was in the public sector, even when development review came in, it's like the planners had their little thing that they looked at, our engineers looked at something else, our city engineer did this, public works, the fire marshal. In every one of those conversations, we need to be the ones that are bringing this up and advancing how we can all work together versus sitting and waiting for our established pipelines to not really get to any of the final solutions. The other part of it is getting up to speed on the topic. And I know Rachel mentioned a few times about this may go too far into depth, and if you really dive into the science, it's crazy complicated and it's can be a little bit scary, but you do need to know enough about it to not get caught off guard. Rachel kind of presented on some of the natural things that are out there. You don't need to know every detail about those natural cycles, but you do need the top 4 to know, yes, the climate has on average been in a pattern for 800,000 years, the Malkovich cycle, because you'll bring it up when you're talking to people about, well, this is just a natural thing. So you need to know what that 800 cycle is, why it was there, and why today is different. But after that, you don't really know too much more about it. And there's like 4 types of those natural things that you just need to have an awareness of, so you don't get caught off guard in a typical conversation when you're talking to community members who are working off sound bites and social media posts and things of that sort. So those are some of the ways. Rachel, do you have others?
Yeah, I mean, I agree with a lot of what you said, Matt. I mean, I think the silo, working in silos is a big problem. And so if you can coordinate meetings like in your city or, where they're cross-departmental meetings and where you can learn from one another and see, because what I've observed is that there's a lot of instances where if people just talk to each other in their departments, in their, in their city, then they would realize, oh, they're all trying to address similar problems, and they'd actually be more effective if they were aware of each other's efforts. So yeah, I would really encourage trying to break down some of those silos. And yeah, I think you covered it, Matt. That was a great answer.
And I'd probably have one more point on that, and that would be we all represent different areas of the country, and different areas of the country have the freedom, I would say, or political cover to speak in certain ways. And if you're in one of those areas where it's not a very, very well received topic of conversation, you can advance the solutions of climate change without ever talking about it. Because when you get down to it, and you'll probably see some of these in the upcoming presentations, things to solve the climate crisis are also oftentimes just good planning. And so you can move the needle forward without even mentioning climate change. And so that's a way to kind of protect our planners out there that may be working under political environments that just, it would be toxic to openly bring this up in a meeting.
And I think that was a really great answer to several very similar questions about dealing with our climate change deniers. Do you have anything else to add to that besides just sort of, working undercover as a good planner and, maybe not necessarily speaking directly to folks that are very avid deniers? Do you have any other comments on how to deal with those types of people?
Yeah, I can speak to that a little bit. I work in a region that is not known for climate action. But we have a lot of weather extremes, and we have a highly variable climate in general. Even just historically, it's highly variable. So a lot of the conversations and kind of introductory meetings I'll have with, in this case, practitioners usually is, talking about the weather extremes and just the natural hazards you face and that sort of thing. And then kind of slowly I'll bring in, like over time as that relationship develops, I'll slowly bring in some of the other, actual like climate science, climate change information with data supporting it, so they can see that it's, it's not just some talking point, it's actually based on this data, some of what I showed today. So, and I've also found that, you'll see stuff on social media or headlines, and you see the political talking heads or even just heads of organizations. And that seems to be a very different kind of conversation point than most of the people who are actually doing the work. And it seems like the people I interact with who are planners and emergency managers and public works officials, if you have a conversation with them one-on-one or even in small groups, they seem much more likely to be willing to have the conversation. And I've never actually had anybody, just shut down a conversation. So I think people are curious, and they often, just the political narratives and stuff will often kind of, you might be scared to have the conversation because of other, higher level conversations. But when you talk one-on-one with somebody, I think they're usually more willing to talk about your issues that you face at a local level.
Catherine Hayo's book is a perfect resource to really get a full book on that question. It's called Saving Us.
Okay, there is a question about the NOAA teams that were doing the special projects in various regions. I think there were 9 of them. There's a big fat hole kind of in the Midwest. Some of the Midwest states that are, up against a lake are included, but what gives? Why not the Midwest? How come there hasn't been a study on that section yet?
Yes, great question. That is due to funding. So although there is currently, if the funding, there's been a bid out to have Kansas, Missouri, Nebraska, and Iowa covered, as well as some other slightly eastern states. And that should be awarded. It should, if the funding all comes through, which I think it, again, it's Congress we're talking about here, that will start next September. So some of that's filling in. And yeah, there are some gaps, and there are people high in NOAA that understand that. And those of us with these recent teams are slowly trying to push and get more of the, get the entire country filled in. There are other organizations doing similar work, and we all kind of have different focuses. So if your state or area was not filled in on that map, there are potentially other organizations that would provide at least similar or some information that would be relevant to you.
Okay, there is another question. There was a quote by the Intergovernmental Panel on Climate Change that you included in one of your slides, Rachel, and it's the science is settled. It is indisputable that human activities are causing climate change, making extreme climate events, including heat waves, heavy rainfall, and droughts more frequent and severe. There are a couple questions kind of related to this. There was one specific to this quote. For those that don't know a lot about this, or for those that are deniers, I guess you're kind of making a very bold statement here. Is there a 1 or 2 sentence elevator speech that we could give those that are unclear about the science or are deniers, that give some really concrete foundational support to the statement?
Great question. I'll do my best to answer this. It's a tough one. I mean, I would say we have data that shows that carbon dioxide is at a level that we haven't seen in any modern times, and that is increasing the temperature of the Earth, which is then basically causing things to go out of whack, to go out of alignment, and creating these, especially precipitation challenges, either too much precipitation or too little. And it's changing the conditions that our societies have been built upon and based on. The rate of change is faster than what we've previously had to deal with.
Okay, we're going to get into, those were some sort of overarching questions. Now there's just a couple kind of science-y sort of questions, I guess. The first one is, how do you feel about mixing the map projections, Mercator versus others? The question says, I worry that this biases the message if it's meant to be a simple message. What is your thinking behind changing map projections to display data? I'm not entirely, I don't know what slide.
So I'm guessing there's
two, so maybe you do.
I don't know a lot about, like, I'm not a geographer, so I don't know all the details, but I'm thinking what they mean is that if you have a flat map versus showing, the curved version, like more represents the actual globe, that it could influence how you're viewing the projection data. But I'm thinking that when these modelers put out the maps, they're accounting for all that in how the data is being displayed. So again, this is not, it's a little bit outside my area of expertise, but I'm assuming that they're accounting for that because there's some people that know what they're doing in that area. And I don't think anyone, at least the people that I've ever interacted with, aren't trying to mislead anyone and are trying to do, be the most accurate that they can to make sure the data is the best that we, that it can be.
Another possible answer or way to look at that would be talking about projections. And as Rachel kind of overviewed in her presentation about the level of detail and quality of the data set has increasingly over the decades been more and more refined, more and more minute. But one of the things they do in these models is when they work on developing the models for projections, they take the new stuff that they've added into it and they start to retroactively apply it backwards to make sure that it's resulting in the historical data that actually occurred. And so they back test these models to make sure, the new influence of, geologic movement of land, whatever the new information database is, they apply it to the existing models back on historical data to make sure that it actually results in what actually happened, to further and further refine the accuracy of these changing cycles and changing levels of data that is just growing across the world right now.
We have some map nerds on this call today, and they have some strong feelings, and I love it. The notes are coming in. I think we need to have a session on this, is what I think, for those that are super interested in this, and that, we need people like them. So it's good that they're here and that they're on the call with us today. So thank you for being here. The next question that I have, you showed in the presentation that CO2 only accounts for a very tiny percentage of the gases. Does this percentage, is it increasing significantly in recent years? And is it making any kind of impact that we need to be concerned about?
Yeah, you know what? I actually need to look at how, it's still such a small percent, and yet, like I said, the warming potential is what the problem is, and it's changing. So relative to all these other gases, again, most of it's nitrogen and oxygen, it's a very small percent, but its influence is significant. But I do need to look and see if, has that 0.033% actually changed? Like, is it 0.034% now? So admittedly, I have not looked at that, and that's a really good question. Now that it's the parts per million number is so much higher than it was. I mean, it's basically, was it 300, low 300s, and now it's in the low 400s. So that's a, 30%, 32% increase. So I'll need to look into that. Great question.
It's time to wrap up. We still have so many great questions in the queue, so be sure to join us for the next edition that we have coming up on this topic. And I guess if I would say, if there's one takeaway with the discussion today for us planners, is to make sure that we reiterate to friends, family, colleagues that for sure that there is a difference between weather and climate. I think that's one of the biggest things that people are willing to spout off right away is, well, look at it outside. Where's this global warming at? Well, climate is different than weather. So I guess if I would say there's one thing that you would start a conversation with, that would be it. And I thank you to all of the planners who are on the line today, because obviously you understand the importance of climate change and how it is already and will be impacting our communities in the future for years to come. So again, thanks to all of our panelists today and the Sustainable Communities Division for hosting this series. Don't forget to log all those CM credits that you have available. This session is being recorded. It will be available on our YouTube channel, probably sometime on Monday. You can head over to youtube.com/planningwebcast. And then lastly, there have been so many folks asking for this slide deck. I'm going to go ahead and turn it into a PDF, and if it's all right with our presenters, post it on our website, ohioplanning.org/planningwebcast. think that's it for all those housekeeping items. Folks, if you have more questions or you want to reach out directly to our panelists, please feel free. And I think that's it. Anyone else? Thanks again. This was a great discussion. Thanks for giving us this scientific overview of things. It's important to have.
All right.
And everyone have a great weekend. Bye, everybody.
Bye.